Hi, welcome to another practical session. My name is Saif Ali and we're learning how to do spatial statistics and spatial econometrics with R. Today's topic is how to work with tabular data in R. It's a fairly basic topic. We're not going to touch on a lot of spatial concepts, but it is something that you need to know in the beginning as to how to work with data before you can start doing other things. Before we get into the topic today, let's just recap briefly. We said that excellence and mastery over this subject, or really any other subject, is achieved by a combination of understanding and skill. And understanding is gained by listening, reading, thinking, solving things on your own, putting pen to paper. Whereas skill is gained by applying that understanding to real-world problems. And the way to gain skill is by actually doing something, doing it yourself, trying it out, failing, trying again, and keep going, and writing a lot of code. So in other words, the wrong way, the way not to acquire a skill is by watching a lot of lectures. So for example, if you just watch this lecture, read a lot of programming books and forums, you might acquire a lot of information, but you're not going to acquire skill. So I'll just reiterate, they encourage you to follow along as I write code. You should go to your own R studio and try out the same code and come back to the video. That's the best way to learn. That's the way it's going to be fun for you. So with that said, what are we going to do in this session? And what should we know before we go into this session? Let's just talk about that briefly. So what should you know? In terms of understanding, by now you should know what R is, what is R Studio, and what is an R package. This is something that we spoke about, just R fundamentals. You should be basically familiar with the tabular structure of data. So tabular structure is when data is organized as a table in rows and columns. The most common example being Excel. If you worked with Microsoft Excel or Google Sheets, a spreadsheet is the classic example of tabular data. And also it will be helpful to have some basic understanding of programming fundamentals. Like you should know what a data type is. For example, a numeric data type which stores numbers is different from a literal data type that stores letters and symbols and characters. It would be good to know things like a variable, like what is a variable in a programming language, and what is an operator. So examples of operators are plus, minus, division, assignment operators. So these are programming fundamentals. I think all of you will be familiar with them. If you're not, I'll do my best to explain as I go. If you're completely new to programming, then I do recommend, along with this material, quickly reviewing some basic fundamental programming, either from a book or from your favorite videos online. It shouldn't take long. And you should know what the CSV file format is. The CSV file format is a standard file format for storing and transporting tabular data. And this is a file format that is understandable by Excel, by Google Sheets, and also by R. So if you understand this format, you can send data around in a bunch of these programs. Now, in terms of skill, what should you have already done? Well, in order to go into this lecture, you should already have set up your computer for development with R. If you haven't done that, obviously you're not going to be able to follow along with me. You're not going to be able to actually write code. So please do that before going further in this video. It would be a good time to pause right now and set up your computer for R development. And if you want to know how to do that, go back to the previous video in which I show you how to do that. So for this video, I'm assuming that you are ready to go. You have a window open right now, R Studio window open along with this window that you can just quickly tab to try out code. Also, you should have installed the GStat package. This is also something that we did last time. And with that, what will we do now? We will install another package called SP. And the SP package is a package that provides all kinds of methods for spatial data analysis. Then we will take some data and examine it using R, view it, look at its attributes and properties, and then we'll try and export it out to a CSV file, because once you're done working with R, typically you do want to write data out as a CSV file so you can send it to other people or look at it using another program. We'll do some basic stats, not spatial stats, just basic stats on tabular data. And this is exciting. We're actually going to write our very first R script. For some of you, this may be your very first R script that you've ever written. So I hope that you watch till the end. And we're also going to make our very first R plot. So you will have at the end of this video a script that you've written and a plot that you've made using R. So you would have made some progress. So if that's clear, we're going to go ahead. And if you're missing out on any of the prerequisites, please pause now, go back and finish those. All right, so let's transition to our R Studio and do some live code. In the previous video, I had talked about R Studio and the various components of the interface. So therefore, you should be familiar with what we're looking at now. So I have the console here. I have a R script that I have pre-written that we will go through, and I will explain this. And I've already created some data, and this is my files. And if I just tab to this one, this is where I will see the plot that I make. So this should be familiar, I hope. So let's get into the code. So at first, you will notice the color coding, right? The different lines of code are in different colors. So any line that starts with a hash is called a comment. So if you want to write something inside an R script that you don't want R to understand or try and decode, it's just a comment, it's just a note. You put a hash at the beginning of that line. So for example, we had installed some packages last time. So we had installed, remember, the gstat package. So I don't need to run this line of code. So if I don't want to run something, I just comment it out. So if I remove this comment, now it's actually going to run the code. But I don't want this. I've already done this. So I'm going to get rid of this. And I'm going to try and install, as the first step, the SP package. So I'm going to hit save. So if you want to run this line of code, line number 9, then what you do is you click on this button called run. So if you click this, it's going to try and restart R. And now it's trying to restart the. Okay, so what did we get here? So it says package SP is in use and will not be installed. So I'm going to go over here and check if it already has SP. Yeah, so it already has SP. And that's why when I tried to install it, it said the package already is in use and it's not going to. So sometimes you're going to do something, you're going to see an error message. So all of the error messages will appear in the console. So you should know how to read error messages, decode them, and understand what went wrong. So what's happening now is that we already have the package. So I'm going to comment this line out as well because we don't really need it. And now we're ready to load both the gstat and the SP libraries. So I should tell you that when you install a package, it's a one-time affair. You only have to do it once. If you have one R installation, you only have to install every package once ever. But you actually have to load the library every single time. So these commands, library gstat and library SP, you're going to have to run these every time. So I'm just going to run these, and whatever code you run using this button, you will see the results in the console. So you should always be looking at the console to see what happened. So it seems that it loaded the libraries all right. And the next line of code is interesting. It starts with a question mark. So this is called an operator. An operator is a special symbol that has some special meaning to R. And in R, a question mark followed by a package name basically means that you want R to open the help manual for that package. So we want to open the help manual for GStat. So if we run this, it will open the help manual in this viewer pane here on the bottom right. And this is the R documentation for the GStat package. Maybe if I might ask you to do a small exercise here, how would you open the help manual for the SP package? You can pause the video right now and try that out. I'm going to show you how to do it. It's the same thing, SP, question mark SP, and now in the viewer window, you have the help manual for the SP package. And you can go through this and read this, and we will explore these manuals more as we go along. If you want to clear the console, you can press Ctrl L, and it will clear the results in the console. So far, so good. Now, what we want to do is we actually want to start looking at some data, some tabular data. So the SP package actually comes with some data already. It's part of the package. Usually, if you want to look at tabular data, you have to read in some data from outside. I'll show you how to do that a little later, maybe later on in this course. But for now, we'll just use data that comes along with the SP package. And this data set is called Muse. And this is a data set that is it's from some researchers, Burrow and McDonnell, from 1998, and it contains data about heavy metal concentrations along the river bed of a river called Muse. So now we don't know anything about this data, right? We don't know what it contains, what kind of variables it has. So we want to now start exploring and examining this data. So let's go ahead and load it with this command, data Muse. So once you load something, it's going to show up in your environment. So this Muse variable has showed up. So if I already had it. So let's say if I remove this, if you want to remove some data, you can just say remove Muse, right? So it'll get rid of. So now see it's gotten rid of Muse, and if I run this again, it will bring it back. So any data that you have currently loaded in your environment will show up here. And now we want to see what's inside. Let's start opening this up. So this command, class Muse, this tells you what is the type of the Muse variable. So Muse here is the name of a variable. It's a variable that we've created inside the R environment, and every variable has a type. Like I said before, some variables are numeric in nature, so they only store numbers. Some are literal and they store strings. So what is the type of this variable? We can know the type of any variable in R using the class command. So if we run this, it tells you that Muse is a data frame. And a data frame is basically another word for a table. It basically means that it's a table. It's a frame consisting of rows and columns. And every row is an observation, and every column is a variable. So if you look at the data frame in the environment window here, you can see that it has 155 observations of 14 variables. So there are 14 variables, and they've been observed 155 times. Now we actually want to see inside. So we know the dimensions, we know the type, we want to see inside. So one thing you can do is just click on this, right? If you click on this, it will show you the whole data inside this sub window here. And you can see that there are variables called X and Y, so it seems like a location. There's something called cadmium, copper, lead, zinc, elevation, distance, and so on and so forth. So I don't know what all of these mean. Usually, anytime you work with some data, it will come with metadata. Metadata basically means data about data. So you should have some source of metadata which helps you make sense of these, so you don't have to guess. And in this case, the metadata for this data set, I've given the link here in this file. So if you open this PDF, this tells you in detail about what each of these columns mean. Another way to examine data is using the head command. So if you do head muse, what it does is it just shows you the first few rows. This shows you all of the data. So we know that it has 155 rows, but if you just want to look at the first few rows, just get a preview, you can use the head command. You can also use call names. So call names just tells you the names of the columns in the data set. So by now we know the names, X, Y, cadmium, copper, etc. It's the same names that appear in this row right here, the top row. You can look at the dimensions, and you might, before I do this, you might pause the video and think to yourself what the dimensions are. We already know them. It's 155 by 14. So a data frame is like a matrix. It has 155 rows and 14 columns, and each row is an observation and each column is a variable. You can also look at individual elements of the data frame. So this is a new operator. If you put numbers inside these square brackets, it tells you a particular observation, a particular element inside that data frame. So we just want the first element, the first row and the first column. So if we run this, it tells us that the value of this element is 181072. If you open this up, you will see that the first element here, and the first variable and the first row, this is the same value. Try using this square brackets to examine other elements in this data. You can also examine values from a specific column. So suppose I'm an analyst that only cares about zinc concentrations. I don't want any of this other stuff. So I just want to look at this column. So what I can do is I can write the name of the variable, and this is saying that I want the first row, and I only want the first row from the zinc column and not anything else. So if I run this, it tells me that the value is 1022. Again, if you look at the first value inside the zinc column, it's 1022. So these are all just fun ways to look at the data. You can also access individual columns using the dollar operator. So if I run this, it tells me, it basically prints out the whole zinc column. And if I just want the first few values, I do head. So I'm combining the head function with the dollar operator to look at the first few values inside the zinc column, right? So I'm just going through this line by line. You're most likely not going to remember it if you just listen to it. So you can stop now and try to run this code, get till here by yourself before we go further. Okay, welcome back. Now, so the one thing to know is that a data frame is a composite data type. It has many different types of data structured as a table. But each column within that data type, within a data frame, must have a single type. So for example, the zinc column, if we print out the class, the type of that column, we are told that it's a numeric type. So all of the values in a particular column of a data frame have to be of the same type. You can't mix. So if zinc is a numeric data type, then all of the values have to be numbers. You can have different columns that are of different types, but within the same column, you can't have different types. So that's something to keep in mind. Similarly, if we print out the type of the land use column, then we are told that this is something called a factor. You don't need to know what a factor is. All you need to know is that the land use column inside the Muse data, which is this, it seems to have some letters, is a different type from the zinc column. So you can have different types in different columns, but within the same column, all of the data has to be of the same type, right? Okay, so how about if we have this data Muse inside R, but what if we want to export it? Maybe we want to look at it in Microsoft Excel, or we want to upload it to Google Drive, or we want to send it to somebody else. How are we going to do that? Well, you can use a function called write.csv, and then if you write this data out, it writes the first parameter of this function is the name of the data frame that you want to write, and the second is the path to where you want to write it. So if we look at our data folder, we have a CSV called Muse, which will contain the same data that we just exported. So you can use that to export data out of R, tabular data out of R, and then share it with others or look at it in some other software. Okay, so far so good. So that was about examining data. But what if we want to actually do some statistics? So let's print out some summary statistics for the zinc concentrations. So the zinc column contains concentrations of zinc along the river bed. So they measured concentrations of zinc at various locations along the river bed, and that's the data that we want, and this is in parts per million. So we want to see what the summary statistics are. So if you use this command called summary, it summarizes the whole column and tells you what the minimum value is, the maximum, the mean. So we know the mean is 469.7. So on average, the zinc concentration on the river bed is 469 parts per million, 469.7 parts per million. Similarly, you can use the var command to calculate the variance or the standard deviation. And finally, we want to plot this. We want to plot the frequencies of this variable. So we can use a command called hist. And if you want to look at any command, you can type question mark and type the command name, and it will tell you how to use that command. It will bring up that help manual. So when you use hist, you basically just need to provide the variable name of which you want the histogram. And if you run that, it will show you the histogram of that variable in this window right here. So these are the frequencies. We see that values between 0 and 500 are very frequent. And then it kind of, the larger the concentration becomes, you have fewer and fewer values. So it's maybe like an exponential distribution or something. Okay, that's it. That's all the code that we'll discuss today. I hope that you will feel more comfortable working with tabular data in R. And I encourage you to pause the video again and try stuff out for yourself. All right, I hope you had fun trying things out, writing code. I hope you got a lot of errors and you tried again. Just to summarize what we did today, we installed a new package called SP, and we took some data from that package called Muse, and we exported that data out. We used a variety of functions to examine what that data looks like. We learned some new operators. I've given you some useful links here to user manuals for the various packages that we used. So you should feel free to explore these. And once you've done that, you'll be ready for our next practical session, and I will see you then. Thank you so much.